Okay, we're going to start looking at problems 11 through 15 on the 2015 June Geometry Common Core exam. So let's look at number 11. I want you to write this down, what I have written. Okay, and also, let's read the problem. It says, in the diagram of triangle ABC below, so we have A, D, C, so this triangle. EB is parallel. This means parallel. Remember that those two lines up and down, they like that. That means parallel. So EB is parallel to DC. And then they say AE is equal to 9 and ED is equal to 5. Now, what is the length of AC? Now, keep in mind, AC is this entire side, so be careful. You can do a lot of work on this problem and then circle the wrong answer because you don't pay attention to what is being asked. All right, now, I want you to write this down, what I wrote over here. Any line that intersects two sides of a triangle and is parallel to the third side creates similar triangles and proportional parts. So we have that situation here. We have EB, which intersects two sides of the triangle and is parallel to the third side. That's what this says. EB is parallel to DC. So it intersects two sides and is parallel to the third. So we have that situation here. Now, there's a couple different ways. So I'm going to do this different ways here. You could set this up as finding this piece here that I just labeled X. So you can set up like this. 9 over 5 is equal to 9.2 over X. Now you get 9X because you're cross multiplying. You get 9X is equal to 9.2 times 5. So that's going to be 9.2 times 5. And that's 46. And then you want to divide by 9, you get X is equal to 46 divided by 9 is 5.11. Repeating. Now, what they do, and what I know a lot of students do is circle that. Well, remember, they were looking for AC, not BC. 5.1 is BC. Okay, so what you have to do is you have to add AB to BC. So we know AB is 9.2, BC is now 5.1, which means our answer is going to be, add them up. And looks like the answer is number 3. Hopefully you see that. So 14.3. So don't circle 5.1. Don't do all that work and then lose points. That would be a shame. All right? And remember, I want you to try and work on these before I go over them. So we'll go to number 12. But see if you can do it on your own. All right, let's look at number 12. It says, in scalene triangle ABC, shown in the diagram below, measure of angle C is 90. So that tells us that we have a right triangle. When you see these two things, we have a right triangle. Now, it says, which equation is always true? And you have 4 options here. Well, this is going to help us. We talked about this earlier in the year. If you're in my class now, if not, this will be the first time you've seen this. But I want you to write down what I just circled. In a right triangle, the two acute angles have to add up to 90 degrees. So our two acute angles are A and B. Now, we don't know what they are, but if this angle C is 90, and remember, all the angles of a triangle on the interior have to add up to 180. So if this one's already 90, A could be 25. Whatever B is has to add up to 180. So that would have to be 65. So, we don't know exactly what those angles are. We don't know what they are at all, but we do know they have to add up to 90. And you remember if you were here in class, we talked earlier in the year, and I'm going to go to the calculator for this. When two angles add up to 90 degrees, you have sine 30 is equal to, and then cosine of 60. Well, it's interesting that they're equal because the angles add up to 90 degrees. What if it's something different? What about sine of 25 and the cosine of 65? Because those two add up to 90. Oh. Oh. So the sine of 25 and the cosine of 65 equal. So what we learn here is that when those two angles are equal to one another, sine A will equal cosine B if the angles add up to 90 degrees. So what is our answer? Number 4, based on that. Okay, let's look at number 13 now. It says quadrilateral ABCD has diagonals AB and BD. Which information is not sufficient to prove ABCD is a parallelogram? Well, a couple things I want you to write down. You need to know what bisect means. You have bisect in this problem. You need to know what it means in order to answer the question. And that means to cut in half. When two lines bisect one another, if I were to tell you that these two lines bisect one another, that means that this side is equal to this side, and this side is equal to this side, if you know that they bisect. All right, so that's one thing you need to know. I want you to know that these two lines mean parallel. And we talked about that in the problem before. But here I want you to actually write it down. Also, I want you to write down these properties of a parallelogram. The opposite sides are parallel. The opposite sides are congruent. So when I say that, I mean parallelogram could be something like this. It could be just a normal something like that. So the opposite side would be this one, and then these two. All right. The opposite sides congruent, the opposite sides are parallel. So remember, we have parallels, this little sign right here, and right here, parallel. The opposite angles are congruent, so this angle and this angle would be opposite. The consecutive angles are supplementary. When it says consecutive angles, it would mean this one and this one add up to 180 degrees, and the diagonals bisect each other. So when you have diagonals, anytime you have a parallelogram, they are going to bisect one another, so they're going to cut each other in half. All right, so if you look at our answer choices, let's see. So I'm going to draw another parallelogram here. Just a normal one. Like this. All right. Now, number one, if AC and let's actually do this. If AC and BD bisect each other, that means it's a parallelogram. So that is sufficient to prove that it's a parallelogram. So that's not going to be your answer because that information is sufficient. And then AB is congruent to CD, and BC is congruent to AD. And that information is also sufficient. What about AB is congruent to CD, and AB is parallel to CD? That again is enough information to prove. If you look at number 4, it says AB is congruent to CD and BC is congruent to AD. Well, I can draw something that's not a parallelogram that fits that description. I can draw this shape right here, and I can label that A, B, C, D, and well, I have to letter it differently. let me think about that for a second, how I'm going to letter that, and you can think about it also. Okay, I drew another shape here. Actually, I drew pretty much the same shape, but I just lettered it differently. It's still A, B, C, D. But look at the information. It says AB is congruent to CD. That's true. And BC is parallel to CD, to AD rather. So that's all true, but if you notice, this is not a parallelogram. So this right here is not enough information to say something's a parallelogram. Because I just showed you an example that fits what this says, but is definitely not a parallelogram, because AB and CD are definitely not parallel. If you keep them going, they definitely will intersect. So those lines are not parallel. So our answer is 4. All right, looking at number 14. I'm not going to spend too much time on this. We're going to do this probably in about, I don't know, a couple weeks, but I do want to go over it a little bit. I want you to write down the general equation for a circle, which is here. And I'm going to go over this diagram a little bit. You don't have to write this down, but if I have the center of a circle here, and this is my radius labeled R. Now how far, the reason why they have x minus a is whatever this x value is over here. So let's just say that was, I don't know, 1, 2, 3, 4, 5, 6, 7. All right, so let's just say this is 7. All right, this point here, which is the center of the circle, which I'm looking at, if that is labeled AB, that point would be 7 minus a, or just x minus a. And then the y value is going to just be y minus this value. And you can look at that a little more. We're going to talk about that, so I don't want to get too far into that. But the equation for a circle is here, and I do want you to write this down. Now, looking at our equation up here, it says the equation of a circle is x squared plus y squared plus 6y equals 7. What are the coordinates of the center and the length of the radius of the circle? So let's go ahead and figure this out. All right, so we need to complete the square. You guys who took algebra last year, which I'm assuming is everyone, unless you're watching this and you didn't take algebra last year, we're going to complete the square. So we're going to do it for the y value. So to complete the square, we're going to have x squared plus y squared plus 6y. Now what we're going to do is leave a space here, and we already have 7 on the other side. So what's going to go in that space is you take this value, divided by 2, which is going to be 3, and you square it and put it here, and put it right here, so plus 9. Now you also have to do that on the other side, because you don't want to change the value, so we're going to add 9 over there. So now we're going to have x squared. Now this part right here, all right, is just going to turn into y plus 3 squared equals 16. So what we have now, I'm going to write it over here a little neater. We have x squared plus y plus 3 squared equals 16. All right, so the 16 is actually the radius squared. So it's not the radius of the circle, it's actually the radius squared. So our radius is actually going to be 4. So we can eliminate 3 and 4. And whenever you're looking at this equation of a circle, whatever is, first of all, if you don't have anything in parentheses, if you just have x squared, then your x value is going to be 0, which both 1 and 2, the x value is 0. Looking at the y, if there is something in parentheses, whatever the value is, you take the opposite of that number, and that'll be your y value for the center, the coordinates of the center point. So that, since that is a positive 3, our center is actually going to be negative 2 for the y value. All right? So that's going to be answer number 2. Now, if you just have x squared plus y squared is equal to 16, or anything, if you have x squared plus y squared, then your center is 0, 0. If you have anything else, then you have to determine what is the center. So, for example, if you had x minus 1 squared plus y minus 3 squared. Now, let me do this. I'm going to write that again. So let's just say you had x minus 1 squared plus y minus 2 squared equals, let's just say 36. Okay, your coordinates for your center would be 1, positive 2, and then your radius would equal 6. Okay, so we'll talk about this more, but for this particular question, your answer is just 2. All right, let's look at number 15. It says triangles A, B, C, and D, F are drawn below. They have your 2 triangles here. If AB is equal to 9, so let's label these. BC is equal to 15, and DE is 6, EF is 10, angle B is congruent to angle E. Okay, which statement is true? So think about that for a second. Also, I want you to write down what similar triangles, what properties they have, or what do you know when you know you have similar triangles, or what are you looking for? So write that down. All right, so looking at this, let's look at the first one. Is angle CAB congruent to DEF? Well, you have to imagine, based on the fact that E and B are corresponding, you have to imagine that this would end up here. If I were to take this small triangle and rotate it, F would come up here, and E would obviously come right here, right? So keep that in your mind. So CAB, so I'm actually going to write this. I'm going to write this down here. All right, so we have 9, 15. I'm going to erase some of this this blue stuff that I wrote. So we have 9, 15, and let's see, I'm going to do A, B, C. So we have this. It doesn't say it's a right triangle. It might look right, but it doesn't say anywhere in here that's right. All right, then I'm going to draw my other one and try and draw it after I've shifted it. So after I've shifted it, my E is here. Remember, that's corresponding. My F is up here, and my D is here, and my EF is 10, and my ED is 6. Now, is CAB congruent to DEF? Well, CAB is here, DEF is here. That is not true. DEF is that one. That is definitely not true. Let's look at number 2. Is AB over BC? So AB over BC, that's AB over BC. Is that congruent to FE over DE? Well, let's look at that. AB is 9 and CB is 15. Is that equal to FE, which is 10 over 6? Well, you can tell if they're equal or if that's true by just cross multiplying. So is 9 over 15 equal to 10 over 6? Well, it should be pretty clear, hopefully, that 9 over 15 is less than 1 and 10 over 6 is greater than 1. So I don't think they're equal. But if you do multiplying, you get 54. Is that equal to 150? That's our check. Obviously not. So when we cross multiply, it's not going to be the case. They are not equal to one another. So number 2 is not our answer. Let's look at number 3. Are they similar? Well, if they're similar, and this symbol means similar, so I want you to write this down also. This symbol means similar. If they are similar, that means the corresponding sides are proportional or have the same ratio. So our corresponding sides would be this one, so 9 and 6, so 9 over 6. Does that equal 15 over 10? Is that true? So I'm going to take that. How can I see if that's true? Well, I don't know how you're going to do it, but you always can cross multiply. And if the cross products are equal, then you have 2 equal ratios. So we're just going to cross multiply. So we have, does 9 times 10 equal 15 times 6? Well, 90 does in fact equal 90. That means that these must be similar triangles. And you can check the last one, but that one is not going to work either. Okay? So that's it. Hopefully you wrote down everything, and we'll be able to go over more later on.